A-level physics. Welcome once again, members. Let's begin this A-level physics by having a general overview on some of the Greek letters, the mathematical signs, and the conversions done in A-level physics. So I welcome you once again. Let's begin on this now. Some of the Greek letters that we use include the following. So we have the name and the character, and maybe in the topics that we'll be finding these as we go on along this A-level physics. So we have alpha, the symbols there, we have beta, we have gamma. Gamma sometimes written like this, and these letters are somehow familiar if you've not forgotten your modern physics of O level. Then we have the delta, and then this one is for the small changes. So both of these ones here, the deltas are for small changes. This one here specifically is for very small changes, and this one is for those changes which are small, but they are finite. In other words, they can be good. For example, in case you're looking at the change in the temperature as theta 2 minus theta 1. If theta 2 was given as maybe 70 and theta 1 has been given as maybe 69 and the difference is 1, this is a finite difference. Then we have the epsilon. This is normally used for the EMF of cells. We have the kappa for the mesons. This is basically in modern physics. We have the theta. It can be used as an angle. Sometimes can be used as the temperature. So take note of that. Then we have the lambda. Lambda normally used for the wavelength and for the lambda particles. Still among small changes. Then we have the mu. It is read as mu and is used in conversions. Maybe, for example, in the micro, something that is micro, something that is small. For example, 10 micrometers. What is this all about? Shall we be seeing what this is? So this is micro. We have the nu. This is for modern physics. We have the pi. You know what pi is? 22 out of 7. The pi mesons, these are still in modern physics. Then we have the rho, basically used for density and resistivity. Then we have the sigma. Sigma sometimes used in the summations when you're getting the total. Especially this one here is so common. This one shall be seeing it in modern physics and in heat. We're talking about Stephan's law. Then we have the tau, basically used in mathematics as well as in physics. Then we have the phi, used also in work function, modern physics. And then the omega. Omega. This is the omega, and this is also the omega. But this omega here is normally used when it comes to circular motion, gravitation, and it means the angular speed. Then this ohm here, sometimes also mentioned as omega. This ohm here is a symbol of resistance, and actually it is the SI unit of resistance. So those are some of the characters or letters that we use in the physics, as we shall be seeing along the way. Not all of them will be used at this level, but we need to know that they are there as well. Then when you come to the metric system, the conversions of units, we have what we call a kilo. A kilo is written as a small k, and it means 1,000. For example, 10 kilometers, it means 10,000 meters. Then we have the mega, capital M. For example, 10 mega ohms. That means 10 million ohms. So it is a million times 1,000. Then we have the giga, capital G. For example, 10 gigawatts. That is times 10 power 9. In other words, that is 10 billion. So in other words, that is times 10 power 9. Then we have times 10 power 12, that is tera. Then we have times 10 power 15, that is the peta. And then the exa. But these ones, we shall be looking basically at the kilo, the mega, the giga. Most commonly those. So you need to be knowing what they are. And those are for big values. For example, 10 kilometers, 10 mega ohms, 10 gigahertz, giga ohms, gigabytes. You know that computer language. That is for bigger expression, bigger numbers. Then we also have the smaller units. For the smaller values, what do we use? We have the deci, we have the centi, we have the milli. These ones are so common. For example, King Henry's daughter Mary drank cold milk. So remember, this conversion is in the metric system. This is kilo, hecto, deca. This is a meter. It can as well be replaced by grams liters, whatever that you want. Then we have the deci, centi, and then the milli. So, for example, if you want to convert 10 decimeters to meters, what do? This is the same as 10 divided by 10, and you get your 1 meter. So that is dividing by 10. In other words, it's the same as times 10 to the power of negative 1. In case you want to convert to meters, or to grams, or to liters. So we have the centi. This is the same as dividing by 100, the same as times 10 power negative 2. Then we have micro. This is also common. Shall be having micro. This is dividing by a million. For example, I've talked about this 10 microfarads, 10 or 100 micrometers. What is this equal to? In farads, this is the same as times 10 power. 10 times 10 to power negative 6 farads. Micrometers, this is the same as 100 times 10 power negative 6 meters. So this times 10 power negative 6 is the same as dividing by a million. Then we have the nano. This is times 10 power negative 9. That is dividing by a billion. Then we have the pico, we have the femto, we have the atto. All these are conversions of smaller units to the standard one. So take note of those. We shall be looking basically at milli, micro, and nano. These ones are going to be very common for us when it comes to calculations in some of the topics as we shall be seeing along the way. So let's have some examples of conversions here. Very few of them. Of course, you can pause the video and try out all of them. I know they are simple, some of them. Don't get confused. Just note that where we have this meter here, this is the SI of a meter, is the SI of length. So from millimeters to meters, kilometers to meters, micrometers to meters. Then you have this capital F is the SI of capacitance. So don't get confused of what it is at the moment. Just convert everything to farads. Then this C, which is a coulomb, this is the SI of charge. So it is capital C. So just convert to coulombs. Then we have this K is the SI of temperature, the Kelvin, capital K. So you can pause the video and try all of these. Okay, I know that you've done it already. So just remember that we have the word, the small letter K means kilo. It is 10,000. So this is the same as 50,000 meters. You can as well write it as 50 times 10 power 3 meters. So the choice is yours. So I can simply say here that this is 50 times 10 power 3 meters. Milli means divided by 1,000. So this is, you remember that 1 meter is equal to 1,000 millimeters. So you have 1,000 millimeters equals to 1 meter, meaning that 1 millimeter is the same as 1 over 1,000. So divide by 1,000, meaning that our 4 millimeters would be equal to 1 out of 1,000 times 4, which gives us 4 over 1,000, which gives us 0.004. So you can write your answer here as 0.004 meters, or you can just write it as 4 times 10 power negative 3 meters. The choice is yours, but it is better to use the standard notation. So this is this is 4. So this is 4 times 10 power negative 3 meters. Micro means divided by a million. So this is 0.5 times 10 power negative 6 meters. But in the standard notation, you can write this one as 5 times 10 power negative 7 meters. Okay. Kilo, you know what it means. So it is 100 times 10 power 3 farads. Giga, you know what it is. So you have 4 times 10 power 9 coulombs. And then this is the same as 0.52 times 10 power negative 6 Kelvin, or 5.2 times 10 power negative 7 kelvins. So that is what we don't have. Then we have some mathematical symbols. We have this is greater than, we know that, less than, we have much, much greater than, then much, much less than, then this is greater than or equal to, less than or equal to, approximately equal to, not equal to. This is an equivalence symbol. We have the square root, we have the mean value. Sometimes we use this as the mean value, or we can use it as x bar. It is similar to that one from mathematics. Then you have the mean square value. You shall be looking at this. This is common. Then we have the root mean square. We can also use the CR like that. We shall be seeing this under heat, gas laws. Then we have the proportional symbol. This is for proportionality. For example, y is proportional to x, or y is inversely proportional to x. You know what these are all mathematical expressions. So this means that y increases as x increases. This means that y increases as y reduces, and vice versa. This is for finite changes. I talked about it. This is for extremely small changes. And then this is for the sum. This is for infinity, among the many. So shall be seeing all of these. And let's have a quiz in the next part as far as conversion is concerned. Enjoy.